Hello, Miss Munoz. I'm here today to teach you chapter 1.1 in our lesson book. I'm here today just to make math seem like a more fun and enjoyable thing, as opposed to, the very boring and horrible thing that it in reality is. So basically, I'm just going to be talking today about graphs and how different functions are being graphed and, try to run over that in some fun and innovative ways and make it more engaging for the student. Thank you. So today, first off, I'm going to be talking about the Cartesian plane, which is the first lesson in chapter 1.1. Basically, what a Cartesian plane is, I'll just run it down for you really quick. It's basically when two real number lines intersect each other, one being vertical, one being horizontal. So it makes this type of shape. Horrible graph, but you get the basic idea. And we'll just go ahead and draw some different number points on there. So you first start, usually go up to about 5. That's what you've taught us this year. Really good lesson on your part, Miss Munoz. So have different number lines. So basically, on a number line, there are two different lines. One called the y-axis, the other called the x-axis. So when you're graphing something, the first number in an ordered pair is going to be graphed on the x-axis, meaning it's going to go horizontally. The second letter is the y-axis, so it'll be going vertical. So I'm going to start off today by graphing some points for you. Some easy points. So -1 and 2. So that's going to be over -1 and down 2. So it's going to be down here. Next one, +3. So over here, +3, and then up 4. So up to here. Next one's just going to be at the midpoint, so 0, 0, which is pretty easy. The next one, 3, 0, so just over here. So this is basically our end product. I made a nice number line illustrating where each of the points are. As you can see here, I'll highlight it a little better. You can't really see it here. That's basically what it's going to look like. So that's the basic idea of Cartesian plane graph and how to graph something like that. So yeah. So the next thing I'm going to cover is the Pythagorean theorem and the distance formula. So Pythagorean theorem is basically a squared plus b squared equals c squared. Wow. The distance formula is distance equals square root of x squared minus x1 raised to the second, so it's going to be squared, plus y squared minus y1, also squared. That's all the square root. So basically, you can use the Pythagorean theorem and the distance formula kind of hand in hand to, figure things out in a good way. So what I'm going to do is find the distance. I'll write it down. Find distance of -2, 1, and 3, 4. So basically, you start off with the Pythagorean theorem first by plugging, or with the distance formula first by plugging in the various numbers. So it's going to be d equals square root of 3 minus and minus, so negative. So all squared plus 4 minus 1 squared also. So that's going to come out to square root 5 squared plus 3 squared, which is going to equal square root 34, which comes out to about 5.83. Next, you're going to use the Pythagorean theorem to check to see if that's accurate. So you're going to plug in parentheses square root 34 squared equals 3 squared plus 5 squared. Those are your originals. And then so that comes roughly out to 34 equals 34 because the square root is canceled by squared. So these two are canceled, leaving it to be 34 equals 34.
Math. Math. Math.